Hello everyone and welcome to a new lecture. In this video we're going to talk about horizontal asymptotes. In the previous lecture we talked about vertical asymptotes, and we said that vertical asymptotes are lines that crosses the x-axis, and we have our function such that the function gets closer and closer and closer to the line that are the vertical asymptotes, but they never cross them. Okay, so as our axis gets closer and closer to the line, okay, our y values tend to go to infinity or negative infinity. That was a horizontal asymptote, and repeatedly we mentioned that the graph that we have does not cross the vertical asymptote. However, for a horizontal asymptote, things are a little bit different. Okay, for a horizontal asymptote, we can have our graph to cross the horizontal asymptote. So we define horizontal asymptotes to be lines that crosses the y-axis, not the x-axis. They crosses the y-axis. So for a point that you call it A, we will have a horizontal asymptote like that crosses the y-axis, and we define it to be, so the line y equaling to A, okay, is a horizontal asymptote for the function f of x equaling to y. Okay, if y approaches A as x approaches positive and negative infinity. Okay, so if we have a function, and the function that we have, the points on it, when we increase its x values, so for example this point right here and this point, the x values of this function gets bigger and bigger. It goes toward infinity. When we go toward infinity, we see that our y values get closer and closer to the asymptote. Okay, so that is basically horizontal asymptote. The line y equaling to A is a horizontal asymptote for the function f of x equaling to y. If y approaches A, so as we get closer to A, we have our x values going to positive or negative infinity. Or as we go toward positive and negative infinity, we have the y values getting closer and closer to A. That is the definition of a horizontal asymptote. Okay, so I will show you how this happens on Desmos, but before that, let's see how we can find horizontal asymptotes. So suppose we have a rational function, r of x, okay? This rational function has two polynomials, one on top and one on bottom. The one on top is basically an times x to the n plus an minus 1 times x to the n minus 1 plus plus a1 times x plus a0. That is one polynomial. The one on bottom is bm x to the m plus bm minus 1 times x to the m minus 1 plus plus b1 times x plus b0. So we have this rational function. Okay, so the degree of the polynomial on top is n, and the degree of the polynomial bottom is m. Okay, so how can we find the horizontal asymptote of this rational function? Well, depending on the degree of the polynomial on top and the degree of the polynomial on bottom, we will have different horizontal asymptotes. Okay, so the horizontal asymptote of a rational function, okay, depends on the degree, as I mentioned, of the polynomial on top and the polynomial on bottom. Okay, so the horizontal asymptote, if we have n to be less than m, meaning the degree of the polynomial on top is less than the one that is on bottom, then we have the horizontal asymptote to equal to y equaling to 0. This is the horizontal asymptote. So if the degree of the polynomial on top is less than the degree of the polynomial on bottom, the horizontal asymptote basically equals to y equaling to 0. If they are equal, meaning the degree of the polynomial on top equals to the one that is in bottom, then we have the horizontal asymptote equaling to an over bn. Basically, you're just going to take the two leading coefficients with the leading terms and the quotient of them, so an over bn will be the horizontal asymptote. Okay, if we have n being greater than m, meaning the degree of the polynomial on top is greater than the one that is on bottom, then it has no horizontal asymptote. Okay, so that is basically how you find the horizontal asymptote of rational functions. You look at the degree of the polynomials that is on top and bottom. If they are the same, then an over bn is the horizontal asymptote. If the one on top is greater than the one on bottom, then we have no horizontal asymptote. If the one on top is less than the one on bottom, then the horizontal asymptote equals to y equaling to 0. So let me give you an example. So example 1. Suppose I have 3x to the 2 minus 2x minus 1 over 2x to the 2 plus 3x minus 2. And I am asking you to find me the horizontal asymptote of this rational function. Well, let's see what are the degrees of each polynomial, one on top and one on bottom. So the degree of the one that is on top equals to 2. The one that is on bottom equals to 2. So both degrees are equal. So n equals to m. That means an over bn is the horizontal asymptote. So what is the leading coefficient with the leading term? Well, it is 3, the one for top, and 2 is the one for bottom. So the horizontal asymptote of this rational function basically equals to 3 over 2. As simple as that. Okay? So let me give you another example. So example 2. Suppose I have this rational function. Suppose I have 2x minus 4 over x to the 2 plus x minus 2. Okay, what is the horizontal asymptote of this rational function? Well, the degree of the polynomial on top equals to 1, the one on bottom equals to 2. So n is less than m. Okay, so what case do we have? Well, if n is less than m, then the horizontal asymptote basically equals to y equaling to 0. Then the horizontal asymptote equals to y equaling to 0. Okay, that is the horizontal asymptote of this rational function. It's very, very simple and very, very straightforward. So example 3, suppose I have this rational function. I have 2x to the 2 plus 6 over 6x plus 3. What is the horizontal asymptote of this rational function? Well, since the degree of the polynomial on top is greater than the one on bottom, it has no horizontal asymptote. Okay, just like we can see right here, if the degree of the polynomial on top is greater than the one on bottom, it has no horizontal asymptote. If they are equal, then the horizontal asymptote equals to an over bn. And if the one on top is less than the one on bottom, then the horizontal asymptote equals to y equaling to 0. Okay, that is basically how we can find horizontal asymptotes of rational functions. Okay, so let's go on this mode and check out what happens to our y as we make our x go toward infinity and negative infinity. So we are on this mouse. If we look at the first function that or the first rational function that we found the horizontal asymptote of, it was 3x to the 2 minus 2x minus 1 over 2x to the 2 plus 3x minus 2. Okay, so 3x to the 2 minus 2x minus 1 over 2x to the 2 plus 3x minus 2. As you can see, we found the horizontal asymptote to be 3 over 2, since both degrees, the degree of the polynomial on top and bottom, they are equal. So at y equaling to 3 over 2, this is the horizontal asymptote. Okay, so as you can see, our function crosses the asymptote. So when we talked about vertical asymptotes, only then we had functions approaching the vertical asymptote and never crossing it. However, for horizontal asymptote, the definition was that as I tend to go toward infinity, so as x goes toward infinity and minus infinity, my function approaches the asymptote. Okay? So as you can see, as I go toward negative infinity, so if I zoom in, my function approaches the horizontal asymptote, and the distance between them tend to go toward 0 when I go toward negative infinity or positive infinity. So even if I go toward positive infinity, okay, let's go to the center, which is right here. So if I go to this direction like that, my function gets closer and closer to the asymptote, to the horizontal asymptote, okay? As you can see right here, the distance between them tend to go toward 0 as I make my x's go toward positive and negative infinity. That was the definition of a horizontal asymptote. And with this, we come to the end of this lecture.